Okay, so let me share my screen with you. All right, and then I finally got my pen replaced. Let's see here. All right, here we go. So we're going to start with example 3. In example 3, we're also dealing with partial fraction decomposition. Just understand that what makes this one unique is that one of your factors is a trinomial. So we're going to start with the numerator 3x squared plus 17x plus 14. And we're going to divide that by x minus 2 times x squared plus 2x plus 4. This is what makes it unique, this right here. This makes it very unique. And this is why when we do the setup for this and we re-express this, so again, I'm going to just rewrite the question. Okay, and so this will remain over a, or a over x minus 2, but this part changes. It's no longer just b, it's bx plus c. So this becomes a over x minus 2, so that's normal. But this part, because it's a trinomial, we have bx plus c as our numerator, and all of that over x squared plus 2x plus 4. Okay, again, this is why we have this setup up here. Basically ties right back to the fact that this is a trinomial. Okay? After that, we're in essence doing the same steps that we did in the first two. So we're going to multiply by the LCM. So we're going to multiply both sides. In this case, x minus 2 times x squared plus 2x plus 4 on both sides. So, you know, if I repeat this over here, it just simply cancels, but I'll write it just to remind you. So just remember that this piece cancels with all of this down here. And that's why on the left-hand side, you're left with just the numerator, 3x squared plus 17x plus 14. And now on this side, because we're multiplying this, all of this against both fractions, they in essence get multiplied by their opposite or by the remaining part of the denominator. So you're left with a times the x squared plus 2x plus 4, because the x minus 2's would cancel on this side. So in theory, this cancels with this once you multiply it out. And when you go to the second fraction, so now we have the plus the bx plus c. Notice I'm putting it in parentheses. What's going to happen when you multiply those two, then now these two cancel. And then you're left with just the x minus 2. All right, and so if you distribute the a and you FOIL the bx plus c times x minus 2, then we would be able to solve for the x squared term, the x term, and the constant. All right, and so the next step is re-expressing. So if I have 3x squared, here's my x term, 17x, here's my constant, plus 14. This is equal to ax squared plus 2ax plus 4a. And now on this part, if you don't feel comfortable foiling, since you don't have numbers, you can just distribute. So you'll have plus bx squared minus 2bx plus cx, and then minus 2c. So basically that's those last two terms. Are you with me up to now? So far, so good? No, yes, no?
Yes.
Okay. This is the x squared term. Notice I have 2. On the right-hand side, I have 2. So if I took them and I re-expressed them, I would have a plus b I'm getting the a and the b from here. And notice that these are my x squared terms. And so that's my x squared term. I don't really care about that. I care about the coefficient. Notice that I said now a plus b is 3. In the green, notice the 17x. So I'm going to look at all of my x terms. So ignoring the x itself, I have 2a plus b, no, minus 2b minus 2b plus c is equal to 17. Are you following me with that one? In light blue, notice that I have 4a minus 2c, and that's my 14. That's my constant value. So I know that 4a minus 2c, and that gives me 14. Now on this one, a few students got stuck in solving for the equation, and I would caution you to start looking at these two. I can solve for b in terms of a, which would make this an ac term and then cancel c. So I'm looking at these two as my final cancellation. So if I solve for this one and I say, well, I know that b is equal to 3 minus a, then I can take this 3 minus a and get rid of that b right there. So this second sentence becomes 2a minus 2 times 3 minus a plus c is equal to 17. Do you see where I'm going with this logic? I'm trying to make it so that I only have a and c terms, and I'll cancel one or the other at this point. So if I continue to solve, this gives me 2a minus 6 plus 2a plus c is 17. This will end up giving me 4a plus c is equal to 23. Because remember, I'm going to add that 6 to both sides. I'm combining my 2a's, two 2a's, which is 4a plus c, and then that's where I get the 23. And now this is where I lost some students, and I said, well, now bring this one down. This is 4a minus 2c equals 14. Now that this one looks like the other one, in terms of variables, I have both a's and c's. I can simply multiply this top by -2 or by +2 if I wanted to, which would make this top over here 8a plus 2c equal to 2 times 23, 46, and then bring the 4a minus 2c over, and that is equal to 14. Notice I end up with 12a.
Dr. Barraza,
Talk to me.
you don't have to do all that because at that point in time they both have 4a. So can't you just multiply 1 by -1?
I was going to suggest that you can also do that,
Oh.
but in this case, if you solve for a, you get a is 5 in this route. If you go with your route, you would solve for c. So you would have, let's say we did negative on the top. Let's say you would end up with this. Here's your positive 4a minus 2c, and that's 14. So the a's would cancel. If you did that route, then you get 3c equals, and then -23 and then plus 14, that will give you -9. So c is equal to +3. Notice we just killed 2 birds with 1 stone, technically. We also can solve for a in this case, or for b, I should say, because b is equal to 3 minus 5, which gives you -2. You've got the whole solution already done. Done, son. Okay, so if you noticed, either approach would have worked. You choose whatever works for you. And we're not done though. The final answer for this one in particular, will end up being 5 over x minus 2 plus, and then we ended up with -2, so -2x plus 3 over the trinomial, which is our x squared plus 2x plus 4. All right. How do you feel about this one?
The same about the other one.
About the same? Okay. You didn't find it a little easier?
I like this one more because, yeah, it's easier.
Okay. Let me give you this one to try on your own. So the question stem is always going to say find the partial fraction decomposition of, and then they're going to give you the equation. Remember, they're not going to tell you this has two distinct linear factors, or this has a repeating factor, or this has a trinomial, or this one has a repeated trinomial. They're not going to tell you that. You got to figure that out. So far we've done 3 of the 4. All right, so go ahead and try to solve for this one. I'm going to give you 5 minutes on my timer. And let's check notes in 5 minutes. All right, for those of you that are almost done, let me give you the answers, and then we'll talk about whether or not you think you got this process correct. So you should have 2 over x plus 3 plus 6x minus 8 all over x squared plus x plus 2. All right, so talk to me and tell me if you're on your way to get that, or if you have issues, you want to see it done. What's going on?
Personally, I'm not done yet.
Okay, keep working and see. Are you on your way?
Yeah.
Is there anybody who did it and got it correct?
I have a question about the like the first part of it where we separate the a and then over the fraction and
Okay.
the x and
Okay.
c. So since the numerator is -20, would that make c negative, like bx minus c, or would it still stay positive?
Keep it as it is.
Okay, thank you.
The number itself will likely be a negative, but this is how the setup begins, regardless.
Okay,
And
got it.
so, yeah, so we already know that this is going to stay as 8x squared plus the 12x minus 20. And at least we know that much. We know that this is going to disappear anyway, but I'll write it just for the sake of giving you just a little bit of a nudge. So when we multiply by the LCM, we know that this cancels on this side, and on this side, it's almost like they get cross multiplied, basically. So you end up with 8x squared plus 12x minus 20, and this is going to be equal to a times the x squared plus x plus 2 plus the binomial of the bx plus c, all of that times the x plus 3. So if you set it up to start this way, we're on a good track. So the next thing we're going to do is we got to FOIL here, and we got to distribute all 3 terms, the a to all 3 terms. So you have 8x squared plus 12x minus 20 is equal to 8x squared plus ax plus 2a plus bx squared, and all I'm doing there is distributing, plus 3bx, again distributing, and now distribute the c plus cx and distribute again plus 3c. Okay, and now if you follow the color code, notice the 8 is an orange. 8 belongs to the x squares. My ax squared and bx squared, those two get united. And so at least I know that a plus b has to equal 8. Here's your 12x. So these are the x terms. So that's ax, 3bx, and cx. Now forget the x, because I'm only focusing on the coefficient. So I'm going to look at a plus 3b plus c is equal to 12. And then the last term is the constant, -20. That's going to be the 2a and the 3c. So I know that 2a plus the 3c is equal to -20. Now I've got a system of equations to work out. When I see this, I see that AC is predominant here, and I know that I can solve for B in terms of A. So I can say then that B is equal to 8 minus A, and I'm going to throw that in here. So that this line now becomes A plus 3 times 8 minus A plus C is equal to 12. The reasoning for that is I want to cancel the A and the C's respectively and solve for one or the other, and then that'll help me solve the equation. So I'm still solving the second line here. So I have A plus 24 minus 3A plus C is equal to 12. If I take these and combine them, I have negative 2A plus C is equal to negative 12. Because remember, I'm going to subtract that 24 on both sides. So that's how I end up with the negative 12. So now I combine these two, which is the whole point of my doing the 2A or the B in terms of C, so I can solve for that. So I have 2A plus 3C is equal to negative 20. Notice that the 2A's are opposite signs. So these two are going to cancel because that's a negative, this is a positive. I'm left with 4C is equal to negative 32, and therefore C has to be equal to negative 8. Okay, great. So that means that 2 times A plus 3 times negative 8 is equal to negative 20. So 2A is equal to positive 4. In other words, this is negative 24. I'm going to add it to both sides. So I have a positive 24, canceling that out, leaving me a positive 4. So A is 2. Because A is 2, I know that B is equal to 6 because 8 minus 2 is 6. So B is going to be equal to 6. Final answer is what I gave you up here. A is 2, B is 6, and C is negative 8. Are we still speaking to each other? How does it feel? Are you getting it?
Yeah, it's actually
Yeah.
not that hard.
No, you're good. You're good. Good. Okay, so the fourth and final example, and as I do this, I'm going to just take a step back. This is talk for a minute. Example 1. The difference is, yes, it's partial fraction decomposition. That's all, the entire chapter. But the difference in example 1 is you had 2 distinct linear factors. In other words, you had a clean binomial, right? You had like an A minus B, A plus times a C plus D kind of thing. So you had, some like a 5x minus 1 over, say, x minus 2 times x plus 3. These are distinct linear factors. So we only used A and B as numerators. That's the gist of the first example. And we did the same procedure. We did all of that distribution, LCM, all that stuff. In example 2, basically the same thing. We did partial fraction decomposition all over again, but this time we had a repeating factor. And you know that because when we did this, you had something like, let's say you use the same 5x minus 1, but this was like x minus 2 squared or something like that, right? Example 3, the gist of this one again is also partial fraction decomposition, but now you have a trinomial is involved. You have a trinomial in the bottom. So you have like a 5x minus 1, and then this is something like x squared plus, 3x plus 2, and then you have some other x minus 1 here or something like that. All right, and so that's that one. So that's the first 3 that we've done. The last one we're going to do is example 4. And this concludes this chapter, which is 8.3 basically. We're also doing partial fraction decomposition, but this time with a repeated quadratic quadratic factor. A repeated quadratic factor. This looks like this. Find the partial fraction decomposition of. Now remember, on a quiz or test, they're not going to tell you, hey, this is a repeated quadratic factor. They're not going to tell you that. Or, hey, this is two distinct linear factors. They're not going to tell you that. You have to recognize that and know which of the formulations to implement. So on this one, they're going to give you 5x cubed minus 3x squared plus 7x minus 3, and all of that over x squared plus 1 squared. A repeated quadratic factor. So I want you to remember, and I know that you kind of resisted this idea initially. I don't know if you've gotten over that or not. Some of you were a little hesitant to recognize that this has a power of 2. And so we have to recognize the single of this answer. So this answer will become ax plus b because it's a quadratic. And we're going to use the first power of this. So I'm going to write the 1 just to remind you. We normally don't do that. Plus the cx plus d of the power of 2 of that same quadratic. Just like I showed you last time, I said do the power of 1 and the power of 2 of that same repeated value. So in this case, because it's a quadratic, we have to include the x's. So it's not an a, a b, a c, it's an ax plus b, a cx plus d. So guess what we do? We're going to multiply by the denominator, which is basically x squared plus 1 squared on both sides. Okay, once again, it always cancels on this side, leaving you just the numerator. So you're left with 5x cubed minus 3x squared plus 7x minus 3 equal to, and now remember, that's a square multiplied over here. So the single power will cancel with one single power, leaving you ax plus b times at least the first power of x squared plus 1 to the 1 power, where this one will cancel entirely, the cx plus d. And that's what you're left with. Okay, so this is a FOIL. It's not a big deal. So you have 5x cubed minus the 3x squared plus 7x minus 3, and this is equal to ax cubed. So if I distribute plus ax plus bx squared plus b plus cx plus d. Okay, and now let's just use our common sense. X cubes, I've only got 1. So guess what a is equal to? A is going to be equal to 5. That's given to us in a sense. X squares, I've only got 1x squared here. Guess what this is? So that means that b is going to be equal to -3. Now, this is where it gets, again, going back to the sentences. This is ax, that's a cx. So I know that a plus c is equal to 7. So a plus c is equal to 7. And then lastly, if I do the constants b plus d, that tells me that, I don't like that I use that color, but okay. Let's use the pink. B plus d. Well, that has to equal to -3. And we already know that if I have b plus d is equal to -3, and this is b, then d has to be 0. So I know at least that d is 0 already. If A is 5, 5 plus 2 is 7. I know that C is equal to 2. Done, son. Now we just fill it in and we'll be done shortly. So I know that this final answer should be 5x minus 3 over the x squared plus 1 to the first power plus the negative 3. I'm sorry, the 2x, my bad. The 2x over the x squared plus 1 squared. Remember, the d is 0, so it's not like we're going to do plus 0. We don't really do that kind of math. So leave it out. A lot of students in the prior class found this question to be easiest of all. At the end, anyway. So how do most of you feel?
I feel the exact same way.
Could you explain the B plus D again?
Oh, right here. Okay, so we already know that B is negative 3, right? We already know that B is a constant, D is a constant. So B plus D as a constant is going to equal our negative 3. I already know that B is negative 3. So negative 3 plus what? D is equal to negative 3. D has to be equal to 0.
Okay, thank you.
Because I'm going to add that 3 to both sides to get negative 3 plus 3, which is 0. So we don't write this. I just wrote it to be jovial, but technically that we don't write it. We know it's a 0. Because you always have to go back and fill in the top of these. That's what the partial fraction decomposition is all about. So look, if the application of this doesn't come to you right away, I want you to take my word for it that it's used a lot in chemistry, and it will probably be used a lot in biomedical sciences. When you're breaking up tumors, you're breaking up cells, you're breaking something up, whether it be chemical or what have you. So let me give you one to try and we'll call it a day. So find the partial fraction decomposition of, again, they're not going to tell you. You have to recognize the difference. The difference is this is a quadratic and it's repeated. And so therefore you follow this pattern up here. What did I do today? All right, so go ahead, try this question. I'll give you 5 minutes and then we'll talk. Go ahead and start.
Dr. Barrazo,
Mhm.
what do we do since there's no x squared in the numerator?
Nothing. You're just going to set it up the same way. So you start with a over the single version of this, which is simply x squared plus 1, plus b over the power of 2 of this, which is x squared plus 1 squared, and continue. So after this, remember, you're multiplying by the common denominator, and then it reduces. Keep working. Doesn't matter. We're not dividing anything.
Okay, thank you.
Mhm. It's funny, I never even noticed that. I'm sorry, I wrote this and I was not paying attention. Hopefully most of you ignore me. So the question with the x squared, remember that this is 2x squared plus 2x cubed plus 0x squared plus 1x plus 3. So keep that in mind so that when you do the analysis of the values of each of the variables, you'll understand that 2, a is equal to 2, for example. As far as x squares, it's only the b, and so therefore b has to be equal to 0. There's only one x squared right here, and that's going to be equal to 0. You then focus on ax and cx, so we know that a plus c is equal to 1 because that's your x term. And second to last to remember is the d, which is the b plus d is equal to 3. Since we already know in this case that b is 0, then 0 plus d is equal to 3, and therefore d is equal to 3. So we know b is equal to 0. We know a is equal to 2. Who are we missing? I think we're missing c. And for this to be true, 2 minus 1, so c has to be -1. And so if we write this answer down, this will be 2x over the x squared plus 1 to the first power plus the cx plus d, so that'll be -x plus 3 over our x squared plus 1 squared. So yeah, so the question you had initially, just fill it in with the 0x squared. I thought you meant in the setup. In the setup, other than this, that doesn't really matter. Okay, if you think you have this topic or this question, do you have any questions on it?
No, I feel comfortable.
Okay, then in that case, let me help you feel uncomfortable. I'll give you 2 challenge questions. Are you ready? I should give these to everybody in the other class too. Let's see. If you can do these questions, I say that you mastered examples 3 and 4. So this is challenge question number 1. I'm going to give you challenge question number 2. And no, this just happens to be coincidence that they start with 4x squared. All right, Jesus. All right, see if you could do those two questions. Chewy's here. By the way, any of you guys with dogs and cats that are on any type of medication for intestinal worms, I would use Interceptor. Totally unrelated to the class. Supposedly doesn't cause seizures or any problems for your pet.
Dr. Barroso, is it okay if you can just show us how you set up the A, B, and C thing?
Okay, remember you're talking about for the first one?
Oh, yeah.
Remember the first one is a trinomial. Remember the rule for trinomial?
Yeah, that's why I was wondering, like, would it be like A over x cubed minus 8 and then plus bx plus c over x cubed minus 8?
Factor this out first. Remember that okay, so remember this is x cubed minus 2x cubed, right? So this is x cubed minus 2x cubed, which means that this is x minus 2 cubed. So when we break this out, your first value is x minus 2. Your next quadratic will be the a term squared. This will be plus 2x, and this will be minus 2 squared, which is plus 4. So this is actually your denominator. So that should be a over x minus 2, and then plus, and then this will be bx plus c over the x squared plus 2x minus 4. Remember trinomials. And then follow the rest of the path.
Is it minus 4 or plus 4? Because when
Could
we
be plus
first,
4. I said plus
Okay.
4. It just depends sometimes, isn't it? I wrote it up here. Okay, so yeah. And then the other one is 18. And for 18, you have 3 distinct factors. So think of it like A, B, and C. Was that Chewy? Yeah. Awesome. Yeah, it's gonna be because it has the dog food in it. It should be a 72-pound bag.
No wonder I couldn't move the
You
box.
couldn't move the box?
I got it inside, but.
There's cookies in there.
Oh, well, no wonder there's.
The interceptor's coming in another order.
Yeah, I gathered. Got it.
Okay, again, remember that the second one is a over x plus b over x plus 1 plus c over x minus 5. These are distinct factors. So you're going to have 3 of them. Let me give you the answers for the 2. And we'll discuss these if you have trouble with them during tutoring tomorrow. Okay, so that's the first one. The second one, your answers for each should be, you should have 3 over x plus -1, or you could do -1 over x plus 1. And then plus 2 over x minus 5. Those are your 2 answers respectively. This is challenge question 1, and this is the answer to challenge question 2. So I just wanted to show you these because these are not, like, they don't give it to you in an example question. So I thought, well, let me throw this at you so you can see it with me and we can work on it, you know, together. And so notice that the second challenge question has 3 distinct factors. So you still have the same process going on there. It's just as we did with the 2 linear factors. Okay, I did record this for you. Let me stop the recording. Hopefully you wrote this down.